10.6 binomial theorem. So the binomial theorem was all about how to expand binomials. Now, the way we do it right now, actually before I do that, remember, this does not work. You cannot just do this. Oh, that's terrible. It's not x squared plus 1. Mostly it's just lazy. That's not the way it works. If there's a plus sign, it's just locked in. So the way we're supposed to do it is do this. X plus 1 times x plus 1. Distribute. And if you do it correctly, you should get x squared plus 2x plus 1. Right? That's what you have to do. Same thing with x plus 1 cubed. Right? It's going to be x plus 1 times x plus 1 times x plus 1. Luckily we know what that is. X squared plus 2x plus 1 times x plus 1. And then from here you can distribute also. Right? So notice it's not going to be x cubed plus 1 cubed. It doesn't work that way. The binomial theorem is an easy way to doing this because like that's not too bad. That's not even too bad. But once you get to here, you really want x plus 1 4 times. And if you're like, yeah, I could do that. Well, then how about here? X plus 1 times x plus 1 9 times. Let's take forever. So binomial theorem is all about easy. So the binomial theorem simply states if you have this to the n power, that it's going to be this. N to the 0, first term, second term, plus la la la, up until you get to this. Now a lot of this doesn't make sense right now. And that's why I keep on, we gotta break this down. So first let's talk about what this means. This is n to 0, which is simply just a formula that says this. And you're like, oh great, now what does that mean? And that's what first thing I want to talk about. What is that? That's called a factorial. It's a very simple formula for factorial. All it is when you see one of those, is what you do is you multiply that first number by all the numbers less than it until you get down to 1. So for example, if I give you 4 factorial, this is 4 times 3 times 2 times 1. 12 times 2 is 24. That's it. If I give you 5 factorial, that's just 5 times 4 times 3 times 2 times 1. Luckily we already know what that is. It's 24 because we just did it. So that's 5 times 24, also known as 120. So if you notice there, 5 factorial is the same thing as saying 5 times 4 factorial, because all of this is 4 factorial. And that's how factorials work. You just multiply all numbers down. So 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. Also, if you want, 6 is the same thing as saying 6 times 5 factorial. Or if you want, 6 times 5 times 4 factorial. All means the same thing. Okay, why is that important? Because that's how we simplify this part, right? So if you see a binomial coefficient, n over r, it can be written like this or like that. All means the same thing. You're going to see it mostly in this form. This is the formula for it. And I will give you that. I just gotta know how to simplify it. So let's say I give you 3 over 1. So based on the formula, it's going to be 3 factorial over the bottom one, and 1 factorial, times 3 minus 1, which is 2 factorial. Now the way we break this up is always the same way. You work with the higher number first. So 3 times 2 times 1 over 1 factorial is just 1. 2 factorial is 2 times 1. Hey, these cancel. 3 over 1 is just 3. Let's do a harder one. Let's do 4 2. Using the formula, it's 4 factorial over 2 factorial, and then subtract them. 4 minus 2 is 2 factorial. So the top is going to be 4 times 3 times 2 times 1. The bottom is 2 times 1. That one's 2 times 1. These cancel. It's times 1. And over here you can reduce if you want. Let's just multiply. 12 over 2, which is 6. Okay, so that's all fine and good, but how about we get to this one? 7 factorial over 3 factorial, and then subtract them 4 factorial. So there's a little bit of easier way to do this. And what it is you take the top number, and you expand that down till you get to the bigger number on the bottom. So what I mean by that, it's like this. So 7 times 6 times 4, 5 times 4 factorial. I'm going to stop there because I know that's going to cancel with the 4 factorial on the bottom. This one I could write out 3 times 2 times 1. So these cancel. If you notice, 3 times 2 times 1 is sitting at 6. That cancels out the 6 there. And all I get is 7 times 5, which is 35. Right, let's use that same trick for 10 over 4. Right, so 10 choose 4. So it's going to be 10 factorial over 4 factorial. Then subtract them, 6 factorial. So the trick here again, write it to the that one meets the bigger one, the top one. That was a sentence. Rewrite the top one so it matches the bottom one. So it's 10 times 9 times 8 times 7 times 6 factorial. Stop there so I know it's going to cancel out. 4 I could just write as 4 times 3 times 2 times 1. These cancel. So then here you got to simplify a little bit. 8 and 4 reduce. 2 and 2 cancel out. And then 3 and 9 reduce a little bit. And I get 10 times 3 times 7. 21 times 10 is 210. So that's how you do that without a calculator. So that's how you do it by hand, I should say. There's actually 3 ways to do this. One is by calculator, I just mentioned. I'll show you that in a second. The other way is called Pascal's triangle. So let's talk about this. Pascal's triangle is just an easy way to simplify that stuff. Now what it is a pattern we have to memorize. So it works this way. So you do 1, you bring 1 down each side. And then the next time we do 1. We add these 2 up. 1 plus 1 is 2. Then we do it again. Add these 2 up. 3. Add these 2 up. 3. Bring down the 1s. Add these up. 4. 6. 4. And you keep on going. That's Pascal's triangle. You just build it. Once you learn how to build it, then you're good. We'll go a couple more rows. So 6, 15, 20, 15, 6. I'm going to do one more row just to show you, right? So bring down the 1s. 7, 21, 35, 35, 21, 7. So that's Pascal's triangle down 7 rows. Like you keep on going for as long as you want. It's always going to work out that way. So how do I use this? Well, let's look at the exact same problems we just did. Right, here's the exact same problems. Minus the 10 ones, then I go 10 rows. So 3, 1, the way this works is like this. If you read Pascal's triangle. This row right here is row 2. How do I know? Because it's a 2 right there. This is row 3, row 4, row 5, row 6, row 7. That's row 2, this is row 1, and this is row 0. Now here's the key. So we want to find 3, 1. So what we're going to go here's row 3. Now the way it works is like this. The key thing about this is start at 0. So right here is 3, 0, 3, 1, 3, 2, 3, 3. I wanted 3, 1. So it's this number right here. So this is just 3. Now let's look at 4, 2. So row 4, 4, 0, 4, 1, 4, 2. So 6. Right, same thing I got up here, 3, 6. And then the last one there, 7, 3. So here's 7, row 7, 7, 0, 7, 1, 7, 2, 7, 3. 35. Just like I got up there. So that's another way of doing it. Right, so far you learned 2 ways to simplify a choose thing, a binomial coefficient. One is doing using the formula sheet, using the formula which I will give you, right? So just simplify it, mathematics. Other way is using Pascal's triangle. And by the way, there's some shortcuts with this based on Pascal's triangle. So like anytime you see n over 0, right? So n0, if you notice, all the zeros are 1. It's automatically 1. If you ever see n over 1, that's the first row. Well, it's whatever row you're talking about. So here, 6, 1 would just be 6. And likewise, if you ever see n over n, well, that's just the last value in the row. So that's also just 1. So there's some like little shortcuts. So that you can know it's like, oh, 3, 1 automatically made 3. If I gave you, let's say for example, 5, 5, 7, 1, 6, 0, right? 5, 5, oh, they're the same, automatically 1 because it's the last row. 7, 1 is always the top number. And then anytime you're over 0, it's just like the last one. It's automatically 1. So there's some shortcuts. What's the other way to do it? On your calculator. So if you bring out your calculator, something like this. The way we do, like, say 3, 1, is we put a 3 down. You go to math over probability, and then NCR. That's what this is. It's choose. So that one, then you put it, and then you put a 1. You get it, 3. Let's look at 7, 3. Right? Someone put 7, math, NCR, 3, 35. Right? So lots of ways to do this. Why did I put 7 over 3? Right? So again, by hand, I expect you know how to do it. Pascal's triangle if you prefer, or with the calculator. So now let's actually do the binomial theorem. So this is the form I will give you, not the form I like though. The form I like is this. If I give you this, binomial theorem says to do this. Take the top number, we start counting at 0. We take the first term and the second term. And then we're going to go up, top number over 1 now, because we're counting up, first term, second term. We're going to keep on doing this, so like n over 2, first term, second term. And we're going to keep on doing this until the top and bottom match. N over n, first term, second term. So you're like, okay, that's not too bad. Well, not done yet. Next, we're going to do powers. So we start, so it's a 0. So the first thing is these two always match. So if that's a 0, this is a 0. That's a 1, this is a 1. That's a 2, this is a 2. If that's an n, that's an n. They always match. Second thing, the power here and the power here have to add up to be that n right there. So in this case, 0 and n, 1 and n minus 1, that'll make more sense later. Like let's say this was a 10, and that's a 1, this would be 9. Right, same thing, if that was a 10, that's a 2, this has to be 8. So we say n minus 2, and n plus what equals n is 0. That is the binomial theorem, right there. I cannot draw a straight line. That's what it is. So let's actually use it to expand something. So this one right here. So if I want to expand this, I'm going to start with a 3 right here. So it's going to be 3 over 0, first term, second term. And then move up, 3, 1, first term, second term. Keep on going, 3, 2, first, second, plus 3, 3, first, second. Right, not done, I gotta do the powers. Now remember the bottom power always matches this number, the second one. And then these two things that add to be 3. So in this case, 0 plus 3, 1 plus 2 would get me 3, 2 plus 1 would get me 3, and 3 plus 0 would get me 3. And that's a setup to it. So you do that, you get already half credit. Now you just gotta know how to simplify this. So first things first, how do we simplify these things? Well, that's Pascal's triangle thing, or use your calculator, or use the formula. That's how we simplify those. That's why we spent those like 10 minutes going over how to do that. So this one's actually really easy to use Pascal's triangle, because right here is row 3, so I know it's gonna be 1, 3, 3, 1. Like it tells you right away. It's just gonna be 1, 3, 3, 1. Again, if you want, right, also the little tricks I taught you. Anytime it's over 0, it's automatically 1. Anytime they're the same, it's automatically 1. Anytime it's over 1, it's automatically 1. And the one I should have said that didn't, if the difference is 1, automatically the top number. That's what I meant here. So that's how I do that, right? Again, I don't care if you use a calculator, Pascal's triangle, or do it by hand. And then next, well, x to the third is just x to the third. So these are being multiplied. Anything to the 0 power is 1. X squared is this x squared. 1 to the 1 is 1. It's going to be multiplied. X to the first is x to the first. 1 squared is 1. X to the 0 is 1. Anything to the 0 power is 1. And 1 cubed is 1. Let me just simplify a little bit. And we are done. That is Pascal's triangle, the most basic form. Let's do another expanding one so you can see the idea. And let's actually do this one. And for our sake, let's make this a 4. So we don't do this forever. Okay, same idea, right? I'm going to start with the power. So 4 over 0, first term, second term. Notice it's a negative. I don't care. I put the negative in there. Then we're going to go next term. 4, 1. That's a 4. First term, second term. And then 4, 2. First term, second term. And then 4, 3. First term, second term. And then finally, 4, 4. So something to that effect. Right, now we gotta do the powers, don't forget. Right, bottom one always matches the second. And then the next power, don't get confused with everything else. All I'm looking at is the powers right here. That's a 0, that's a 4. I gotta make these two add to that number. So it has to be a 4. It's a 1. So this must be a 3 because 1 plus 3 is 4. A 2, 2 plus 2 is 4. 3, 1, 4, 0. Right? Again, that's like half the credit. I'm able to write all that out. You understand what's going on. Now all you gotta do is algebra. Just simplify it. Again, how do we get these? I could do lots of ways. Use your calculator, Pascal's triangle, or do it by hand. I'm going to use the fact that I know anytime it's over 0, it's automatically 1. Anytime it's over a 1, it's automatically a top number. Anytime the difference is 1, it's the top number. Anytime it's over the top, it's 1. So the only one I don't know is 4, 2. So again, I can use a calculator, formula sheet, I'm sorry, by hand, or Pascal's triangle. Right, 4, 2, we did it earlier. 4, 0, 4, 1, 4, 2, so 6. Right, that's all that work. That part is done. Let's move on to the rest of it. W to the 4th is W to the 4th. Anything to the 0 power is automatically 1. W to the 3rd is W cubed. Negative 2y to the first power. Now keep in mind, this is all of it. That 1 goes to both of them. A lot of people mess that up. It's still a negative 2y. A lot of people mess this up also, guys. These are being multiplied. So I should get negative 8w cubed y. So many people give me something like this. And that is so wrong. Right? You're being multiplied, not added, multiplied. Anytime they're in the same little thing here, just multiply them all. So the same thing, multiply all these. W squared is W squared. Now again, watch out, that 2 goes to both of them. So negative 2 squared is 4, y squared is y squared. Again, these are all being multiplied. So I get positive 24 w squared y squared. Over here, w to the first. That 3, watch it, goes to all of them. Negative 2 cubed y cubed. So I get negative 8 y cubed. And again, all being multiplied. So negative 32 w y cubed. Anything to the 0 power is 1. That 4 goes to both of them. So 2 to the 4th, y to the 4th. 2 to the 4th is 16, y to the 4th. All being multiplied. So positive 16 y to the 4th. And then right here, all being multiplied, w to the 4th. Right? I know, it's long. That's the way the binomial theorem works. It's actually still way shorter than multiplying it out 4 times. But that's the binomial theorem in a nutshell. Right, so that's the bad news is it's kind of long. The good news is that I'm not going to ask you to do expand all the way out very often. What I'm going to do instead is do something like this. I'm going to ask you to find me the 6th term of this. So here's the thing to keep in mind. The 6th term, if I go up here, I don't have a 6th term, but let's look for the 3rd term. Let's say I was looking for the 3rd term here. This is the first term, 4, 0. First term. Second term is 4, 1. Third term is 4, 2. It's always going to be 1 less. So if you're looking for a term, it's always 1 less. Right? If you're not sure, just write it out like I'm going to do right here. Right? The 6th term will be 10, 0. 10, 1. 10, 2 is the 3rd term. 10, 3. 10, 4. 10, 5 is the sixth one, right? Right. So if I'm asking for a term number, it's always one less. So how do I do this? Well, let's do what we know, right? No matter what, I know this, right? Highest, that top number right there goes there. First term, second term, right? And the first term is C, the second term is D. That's all I know for now, right? It's 10 goes there, first term, second term. What's next? I want the sixth term, so it's always one less, so it's going to be 6 minus 1 is 5. Okay, what else do we know? Well, 5, that number down here, should match the number right here. And if that's a 5, remember the number right here, these two have to add up to be 10, which in this case happens to also be 5. And that's the setup. You get that far, you get half credit. What's for next? Simplify it. 10, 5, I could do the formula sheet. Sorry, I could do the by hand. It's a little big though. I'm gonna use a calculator. So remember the way we do that, we go 10 math NCR over probability, and then 5, 252. So yeah, good choice. I did not want to do that by hand. C to the 5th is just C to the 5th. D squared is just D squared. And there we go. We found the sixth term. That's simple. That's something that's more like I'm going to ask you on the quiz and test. So let's do a couple more. Make sure we got this. I want the fifth term of this. So before I even look at this, let's set up what we know. I know it has to be an 8. I know the first thing has to be an X, and the second thing has to be a 3Y. Right? That's what I know just from the very start. It could be any question. I know I'm going to have that no matter what. Now I said it wants the fifth term. So that's really the fourth, because it's going to be A4 because we start at A0, A1, A2, right? It's going to be A4 the fifth one. And whatever that one is, matches the one right here. And these two at that would be 8. So again, I got another 4. 8, 4. You can do it by hand. Pascal's triangle. We can do it with a calculator real quick. 8 math over probability NCR. Hit 4. You get 70. That's not too bad. X to the 4th is just X to the 4th. And again, watch out right here. That 4 goes with both of them. You notice it's not a plus sign. I can't. And when it's being multiplied, that goes to both of them. So it's like 3y times 3y times 3y. 3 to the 4th, y to the 4th. That's 81. Y to the 4th. These are all being multiplied. So if you're not sure, use your calculator. Times that by 81. 5670. X4, Y4. Right, again, that's the idea. Just make sure we understand how to do these. Let's look at the sixth term of this one. And then do a couple more. So same idea here, right? Before I even look at this, write out what we know. It's 8, has to be 2C, and it has to be negative 3D. Right, no matter what, that's to me the setup. No matter what. Now I want the sixth term, right? And like we said, it's always one less, so it's going to be 5, because we start at A0. Whatever that is, this has to be the same thing. These two things have to either be 8, so this must be 3. And that's the idea. So figure out what this is. I'm gonna use the formula this time. So it's 8 factorial over 5 factorial, 3 factorial. Remember the way you break it up is you do this one until it matches one of the bottom ones. Then this one you just simplify. 3 times 2 times 1. These cancel. 3 times 2 is 6. I cancel the 6. And with 8 times 7. Oh, I hate 8 times 7. 56. My least favorite multiplication. So that's 56. This 3 goes to both of them. 2 to the 3rd, C to the 3rd. 8, C cubed. That 5 goes to both of them. Negative 3 to the 5th. I don't know. I'm going to put in my calculator. D to the 5th. Let's see. Remember parentheses, negative 3 to the 5th. 243? Yeah. So this is the same thing as saying negative 243. Keep in mind, these are all being multiplied. Don't give me this minus 243. I hate that. They're all being multiplied. So I need 243 times 8 times 56. Ah, crap. Negative 243 times 8 times 56. 56, not 26. So negative 108864. big number, seek 3, D5. Right? So like that, that's binomial theorem. We're going to do a couple more to make sure we got it, and then we're going to do something a little tricky. So on this one, I want the last term. So again, even before I look at that, I know it has to be this, this, and this, right? What's the last term? What's where these match? So that has to be a 5. Well, if that's a 5, that's a 5. And if that's 5 and that's 5, remember 5 plus what equals 5? 0. Look how fast this one is. 5, 5, automatically 1. Anything to 0 power, automatically 1. Y to the 5th, y to the 5th. So that's my answer. Because you're multiplying. Done. Again, look at this one. Before I even start, I know how to start this off. It's 5, 3a, 8b. Right? That's the way I'm always going to start off. Whatever the power is, and then the first term, second term. Now they want the first term. Now remember, we don't start at 1, we start at 0. So if that's a 0, this is a 0. And 0 plus what equals 5? Well, 5. 5 to the 0 is automatically 1. 5 to 0 is automatically 1. 18 to the 0 power is automatically 1. So it's all about this guy right here. Distribute 3 to the 5th, a to the 5th. 243, a to the 5th. That's all I got. So that's the basics of using the binomial theorem. Just write out what you know. Right? It's always the top power over whatever, first term, second term. And just fill it out. Okay, so let's do something a little tricky here. And then last two we'll end up with. So look at this one. They want the x to the third in the expansion of this. Right? So I don't want to turn them. I'm saying, hey, what's the term with x to the 3 in it? So how do we do this? The exact same way. Write out what we know. Highest power is 11, so I'm looking for the 11th. First term, second term. Right? That's what I know. Then now look what I want. I want x3. Well, where's my x at? Right here. So what power does it need? 3. And then now look how it falls. If that's a 3, this has to be a 3. If that's a 3, 3 plus what equals 11? 8. And that's it. We just gotta simplify this. 11.3, I have no idea what 11.3 is. That's what we have calculators for. 11 math NCR 3. 165. 1 to the 8th power is still 1. That 3 goes to both of these, so it's 2 to the 3rd, x to the 3rd. That's 8. Well, I need to multiply 8 times 165. Again, I don't know what that is. So times 8. 1320. X to the 3rd. Right? That's the idea. Let's do one final one that's a little more tricky, but the same concept. I want x10 in the expansion of this. So first, again, let's write out what we know. Has to be a 10 up there because of that. First number has to be 3. Second term is this. Now this is where it gets a little tricky. They want x10. So here's my x. What happens if I put a 10 right here though? That is actually being a 20. It's too big. Right? I need this to be 10. So I gotta put a 5 up here. Because 5 times 2 is 10. So if that's a 5, that makes this a 5 also. If that's a 5, 5 plus what equals 10 is also another 5. That's this one. Right? And then all we do is simplify it. 10c5. We'll use our calculator again, because I think it's going to be pretty big. Not terribly big, but bigger than I want to deal with. So 252. 3 to the 5th is 243. That 5 goes to both of them. So 2 to the 5th, x to the 10. Again, which is the one I wanted. That's why I couldn't put a 10 there, because it would be too big. I want x to the 10. And then now you just got to simplify that. Use the calculator. 252 times 243 times 252 to the 5th, which is 32. And I get that monstrosity, 1959552. I believe that's right. I don't care at this point. X to the 10. And that's the idea.